All right, continuing along with our practice exam here. The second question is going to involve balancing some chemical equations. So it should not be much of a surprise here. We've got, the blanks where the stoichiometric coefficients would go. We need to figure out how to balance these equations. So just going left to right and trying to work through that way. We've got one phosphorus here in phosphorus pentachloride, and one phosphorus over here in H3PO4. That would be phosphoric acid, not something we've talked about naming yet, but phosphorus is fine. There's 5 chlorine atoms here, and there's only one over here on the product side. So the first thing we might want to try is putting a 5 there, because that would balance out the chlorine, right? And that also didn't change the phosphorus. So at that point, phosphorus is good, 1 on each side, chlorine is good, 5 on each side, right? Now if we come back here to hydrogen, right? So in water there's 2 hydrogens, so that means an even number on the reactant side here. If we look over here on the product side, there's 3 here in phosphoric acid, and there's 5 here now in HCl, and that makes a total of 8 hydrogens here on the product side. Well, I can get to 8 back here if I put a 4 in front of the water. And that didn't change the phosphorus or the chlorine that we already looked at. So phosphorus is balanced, chlorine's balanced, hydrogen is balanced. That only leaves water, sorry, not water, oxygen. There's 4 oxygens here in the water, and there's 4 here in the H3PO4. So oxygen is balanced here. So 1, 4, 1, 5 would be the correct way to balance that equation. Okay. Look at the second one here. There's one manganese here, right? Manganese 4 oxide, and 1 manganese over here. This would be manganese 2 chloride. So manganese is fine. 2 oxygens here in the oxide. There's 1 oxygen over here in the water molecule, so I want to start by putting a 2 right there to get a second oxygen. Okay, so now manganese is balanced and oxygen is balanced, right? And since we hadn't done anything to hydrogen yet, changing the hydrogen over here is something we'll have to account for in the future. Right? But that's the next one we come to. Here's hydrogen. So I have 4 hydrogens over here now, and that means I want to have 4 hydrogens over here. So I'll put a 4 here for HCl, which is hydrochloric acid. Depending on the phase, if it's a gas, it'd be hydrogen chloride. If it's a liquid, it would be hydrochloric acid. Okay, that leaves just chlorine. 4 chlorines here now, because I have 4 HCl. Right? There's 2 chlorines here. There's 2 chlorines here. So now it is balanced. So 1, 4, 1, 1, 2 for my coefficients. And again, if you feel more comfortable putting 1s in here, I am okay with that, as we're just starting to learn how to do this. Eventually you want to kind of not have to put in those 1s, but particularly on a test, I can see where there might be some benefit to putting in a 1 to make sure you're counting correctly in terms of the number of atoms. Now, looking at the third one here, KClO3, so that's potassium chlorate, makes potassium chloride and potassium perchlorate over here, 4 oxygens. So potassium starts out okay and chlorine starts out okay. The difference here certainly is going to be the oxygens. 3 on this side, 4 on this side. Right now we might recognize the first place that we can balance those 2 numbers will be their lowest common multiple. So 3 times 4 is 12. I've got to get to 12 oxygens before I can balance the reactant side and the product side in terms of oxygen atoms. So that means I need 4 KClO3s and 3 KClO4s. That'll get me to 12 oxygens, right? And now I just need to account for the fact that I changed something with potassium and chloride, but actually it worked out because I've got 4 potassium here, 4 chlorine here, 3 of each there, but 1 more of each there. So I don't need more than 1 KCl to balance this out. So that would stay a 1 there for KCl, and that equation is balanced. So Right? Keep that in mind. There's some back and forth you may have to go through there to balance your equation, but as long as you keep going, you should be able to get to a point where you're balanced. One thing to keep in mind, if you go through your process and you come out with, say, all even numbers, you want to go back and divide through by 2. You want those coefficients to be the lowest possible values of the numbers that are still integers that represent what is going on in the reaction. Okay, still got a little time, so let's go on to number 3. And number 3 is similar. It kind of combines what we talked about here in question 1 and in question 2, because what we have here is a written out equation. So it's written out in the names of the compounds. So we need to figure out what are the correct formulas for those compounds, and then once it's in that format, we're going to want to balance that equation. So calcium phosphate, calcium is from the second column of the periodic table. It's got a +2 charge. Phosphate, in fact, let me write these down. Phosphate is a polyatomic ion. It's PO4, it's got a 3- charge. +2 minus 3, that means we're going to need 3 calciums, 2 phosphates. So the correct formula for calcium phosphate would be Ca3PO4, right? And since that's a polyatomic ion, I need to put the nest around it twice. Okay. Now, and carbon, so it's reacting with carbon. That shouldn't be too much of a challenge. Carbon is just C, right? Combined to yield, so that would represent the arrow in our reaction. And then the products here are calcium phosphide. So calcium, yeah, +2, we already identified that. Phosphide with the IDE at the end, that's the anion of the element phosphorus. So we find where phosphorus is on the periodic table. It also has a charge of -3, just like phosphate did. So calcium phosphide, we're still ratioing +2 and -3, so that again means we need 3 calciums and 2 phosphorus atoms. And carbon monoxide. So carbon and oxygen, they're both nonmetals, so this is that molecular naming system or covalently bonded compound naming system. The first compound, if there's no prefix, that means there's 1, so there's 1 carbon. Monoxide means 1 oxygen, so the other product here would be CO, right? And then, once you have all those formulas correct, we want to balance that equation. So 3 calciums on each side, that's fine. There's 2 phosphorus here in phosphate and 2 here in the phosphide version, that is fine. But there's 8 oxygens here from 2 phosphates. We need to have 8 oxygens over here. Oxygen is only present in the carbon monoxide, so that would mean we need an 8 in front of carbon monoxide. And putting an 8 in front of carbon monoxide means we need an 8 back here in front of carbon. But once we do that, the equation is balanced. So you should expect a question like this on the test. I think it's important to kind of sync these two ideas together, because if you don't have the right formulas for your molecules, you'll find that it becomes very difficult to balance the equation. So you're not really projecting correct information unless you can get all of those pieces just right. So you need to be able to kind of figure out what the formulas are here, right? But then also apply that to balancing the equation. Okay, after number 3, we're going to be moving into some more mathematical problems. So we'll stop the video there. We'll pick up again on question number 4.